Methods of preparation of haloalkanes. आपको ऐसा लग रहा होगा हम कोई नया टॉपिक पढ़ने जा रहे हैं. We are not going to do anything new. Whatever we have done in class 11th, now just let's make use of those reactions to prepare haloalkane. एल्केन में एक बहुत अच्छी प्रॉपर्टी होती थी. आपको पता है एल्केन में कार्बन हाइड्रोजन बॉन्ड बहुत स्ट्रांग होता है, कुछ भी नहीं कर पाते हैं, बड़े ही लेजी होते हैं. तो अपने को क्या करना पड़ता है, हमें फ्री रेडिकल लगाना पड़ता है और उसके बाद हम उसमें हाइड्रोजनेशन करते थे. और रिएक्शन किसी काम की नहीं होती थी. क्यों नहीं होती थी काम की? क्योंकि मोनो, डाई, ट्राई, टेट्रा कुछ भी चाहो बनता जा रहा है, राइट? सो यूजलेस तो होती थी लेकिन हम उसे हेलोएल्केन बना पाते थे. तो सबसे पहला रिएक्शन जो हम यूज करेंगे क्लास 12th में, दैट इज हाइड्रोजनेशन ऑफ अल्केन. गाइस बिल्कुल ध्यान रखिएगा, इस रिएक्शन से आप कन्वर्जन्स में बहुत 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 मदद पा सकते हैं. तो फर्स्ट इट इज गोइंग टू बी एल्केन एंड हाइड्रोजनेशन ऑफ अल्केन. अभी हम जब स्क्रीन पे जाएंगे तो मैं आपको ये बताऊंगी कि मेथड क्यों बुरा है. एक मैंने आपको लिमिटेशन अभी बताया क्यों बुरा है. सो मेनी बाय प्रोडक्ट्स, हम बाय प्रोडक्ट्स को भी कंट्रोल कर सकते हैं. अगर हमने एल्केन को बहुत ज़्यादा ले लिया और हैलोजन को बहुत थोड़ा सा ले लिया, तब हम ये प्रॉब्लम काफ़ी हद तक कंट्रोल कर सकते हैं. हमें मोनोहेलो प्रोडक्ट मिलेंगे, लेकिन फिर भी ये अच्छा तरीका नहीं है. क्यों नहीं है? थोड़ा सा वेट करिए. क्लास 11th में आपका एक टॉपिक हुआ करता था एल्कीन, बड़ा मज़ेदार था, बड़ा मज़ा आता था. एक डबल बॉन्ड होते थे और डबल बॉन्ड के ऊपर आप जब चाहो दो चीज़ें लेते थे. क्लोरीन लिया, एक Cl यहाँ लगाया डबल बॉन्ड के, दूसरा Cl डबल बॉन्ड के सेकेंड साइड पे लगाया और आपका 1,2 डाइक्लोरो एल्केन बन गया. अच्छा जी, लेकिन आपको तो 1,2 डाइक्लोरो नहीं चाहिए. अगर आपको 1,2 चाहिए, आपको पॉलीहैलाइड चाहिए, तो आप हैलोजन ले सकते हो. बट आपको पॉलीहैलाइड्स नहीं चाहिए, आपको मोनोहैलो चाहिए. यू वांट क्लोरोप्रोपेन, यू वांट 2 क्लोरोप्रोपेन. तो ऐसे में आपको क्या करना पड़ेगा? ऐसे में आप HCl ले लीजिए, HBr ले लीजिए और चाहो तो मार्कोनिक लगाइए, चाहे एंटी मार्कोनिक लगाइए. साइड पे चाहिए तो एंटी मार्कोनिक, बीच में चाहिए तो मार्कोनिक. और अगर सिमेट्रिकल एल्कीन है तो जहां चाहे वहां लगा लो. सो ये आपका सेकंड तरीका हो गया प्रिपेयर करने का. तो मैंने आपको एल्केन से भी बनाया, आपको एल्कीन से भी बताया, राइट? सो मेन तो यही तरीके होते हैं आपके बनाने के, और इसमें एक दो छोटे मोटे तरीके हम और ऐड करते हैं और चलते हैं स्क्रीन की तरफ हेलोएल्केन की प्रिपरेशन के लिए. लेट्स गेट स्टार्टेड विद द मेथड ऑफ प्रिपरेशन ऑफ हेलोएल्केन. Alkanes, it's very simple. We take any alkane, we take Cl2, and in presence of ultraviolet light or very high temperature, because you know CH bond is very strong. So what we get is, although we expect that we should be getting CH3, CH2, CH2Cl, but you know this is 1 degree and this is 2 degrees, so we will have major product as CH3, CH, CH3, that is 2 chloro, right? So this is going to be major product because the reaction is following free radical. We will have byproducts like, here also we have Cl, here also we have Cl, as many Cls. So we have actually, if you see in propane, we have 8 hydrogens. So 1 or all may be replaced. So that is why this is not a preferred method. How we can control this? We can control this and we get only mono halogen, but still it has limited use, because first, how to get, if we have alkane and we have halogen, we have heat. This alkane, if it is taken in excess, or halogen taken in limited amount, we will get only monohalogen. We have more than one type of carbon, 1 degree, 2 degree, 3 degree, or having different environments, something like this. So here if we perform bromination with temperature 2, 3, 4. So and suppose let's number it as 5. So 1 and 5 replacing hydrogen can give identical product, whereas 4 will give a different product, 3 will give a different product, and 2 replacement of hydrogen which is attached to 2 will give a different product. So quickly look at the products which are formed. So these are the products possible. So even for monohalogenation, there are many products. So hence it is not a preferred method. Two ways. Symmetrical or unsymmetrical. Let me take an unsymmetrical alkene. Right? If we take, this is an unsymmetrical alkene. So there are 2 ways. Either I use a symmetrical halogen, so I will get a dihalo, right? So I will get a dihalo, or, right? And if I take HCl, I will use Markovnikov addition, and I will get 2-chloropropane as the major. So here we will get dihalo if we have chlorine, and here we will get monohalo if we have HCl, right? If we have symmetrical alkene, so again we get, there is nothing, so keep adding the way you want, so no rule is required, right? So whenever we use addition across double bond, we use a neutral medium like carbon tetrachloride, right? So I hope you'll be able to write the products. So this is from alkenes and alkanes. If you want, I can show you with alkynes also. How about preparing it from alkynes? Suppose we have this. So, but add HCl, right? So what we will get, you will have CH2, double bond, CCl, CH3, again add HCl. So we have done it in all 11. So you get CH3, C, 1,1. Sorry, 2,2, we get 2,2 dichloropropane. So we can get from alkynes also. If we have alcohol, we can use various ways. How? First, if we use normal HX, right? And we use ZnCl2. And if X is Cl, that is we use HX halogen and anhydrous and conc HCl and anhydrous HCl, we call it Lucas reagent. This is known as Lucas reagent. So what we get is RCl plus H2O, right? This is also known as Group's method, although not given in NCERT, but it is known as Group's method. Let's move on to the second one. If you take NaX plus H2SO4, so NaX and H2SO4, what will it give? It will actually give you NaHSO4 plus HX, right? So if HX is Cl and Br, the reaction will take place. So what we get is, we get again Rx plus NaHSO4 plus H2O, right? So we get an alkyl halide. With NaI, reaction is not possible, because we get Hi which gets oxidized to I2. We get Hi which gets oxidized to I2. We don't get nucleophile. These are all nucleophilic substitution. If we take red phosphorus and chlorine and X2, where we don't take X2 in excess, so we get PCl3 or PX3. So what we'll get? We will get Rx, we get RCl plus H3PO3. In excess we will get PCl5. So it's going to be the same product, only the byproduct will differ. We get HCl and POCl3. So with this, if we have SOCl2, what we call as thionyl chloride. This is the best method. It is the best method to prepare RX or RCl, right? So again we get RCl, SO2 and HCl. This is gas, so we are getting escapable gases. The method is known as Darjun's method. You can take a screenshot of this. RI and for RF, we use special methods. RF, it turns out to be highly explosive for the methods which are used for RCl and RBR. So they are not used. RI, most of it are reversible. Reactions are reversible. So we use different methods. Swartz method, where we take RX, where X is Cl or Br, use it with any heavy salt fluoride. We can take any heavy salt fluoride from transition metal. आप किसी भी metal को pick कर सकते हो. Ag की जगह आप ले सकते हो. Any heavy mercury, cobalt, antimony, any of these you can take. And what you get is, we get RF and AgX. This is known as Swartz reaction. Finkelstein reaction. So what is happening is the NaCl-NaBr is less soluble in dry acetone than solubility of NaI in acetone. As a result, they get precipitated and reaction moves forward. When we take symmetrical or unsymmetrical ethers, where RO bond can be broken, right? We can do it in presence of HX. What we get is RX plus R dash OH, right? Let's move to the last one, silver salt of acid. Hunziker reaction. So here we take silver salt of acid and we take bromine in presence of carbon tetrachloride. Under reflux, what we get is RBr. We get CO2 and we get AgBr, right? So this is how we get alkyl bromide, and the results are best for 1 degree, followed by 2 degree and followed by 3 degree. So if it is alkyl halide is 1 degree, the yield is going to be maximum. So guys, ये तो अपना था method of preparation of haloalkanes. तो मुझे नहीं लगता कि अब इसके बाद आपको कोई दिक्कत होगी. See you in the next class. Take care.